proves that neutrinos have extremely small mass. Japanese scientist Takiki Kajita won the Nobel Prize in Physics in 2015 thanks to this discovery, is one of the most mysterious elementary particles and the latest known to humans. Future research on neutrinos can bring about a revolution in the future. Physics even changes our understanding of the universe. If you drive a spacecraft into a black hole, what will you see? The closest supermassive black hole to Earth is Sagittarius. A star is 26,000 light-years away from us, with a mass 4.4 million times that of the Sun. However, its Schwarzschild radius is only about 12 million kilometers before entering this distance. The first thing you see is the accretion disk of the Black Lake, the brightest part of the Black Lake. Here you will see many strange phenomena. For example, one side of the accretion disk is brighter than the other due to the Doppler effect. The image of the universe behind the black hole is bent around the accretion disk. Due to the gravitational lensing effect, the more distant stars have a slightly blue color, because the black hole bends space-time, making your time pass slower than the distant stars. As you continue to get closer to the black hole, the light in front gets stronger, while the light behind gets darker. This is the result of the aberration effect, showing that you are falling quickly into the black hole. At this time, the image of the black hole seems to shrink, and time on a distant spaceship appears to pass more slowly than the first boundary behind the accretion disk. Normally, all matter will be torn apart in the accretion disk. But if the ship can withstand the pressure and pass through the accretion disk, it will reach the photon sphere layer where light can orbit the black hole. When entering this area, all light will be swallowed by the black hole from the perspective of an outside observer. The process of approaching the black hole is endless, and eventually your image will freeze on the event horizon of the black hole. But in your subjective perception, you are still falling rapidly into the black hole. According to current laws of physics, scientists do not know what is inside of the black hole. But according to the theory of relativity, inside the black hole will fill part of the sky stars due to the aberration effect. The real part belongs to the vision of the black hole is only about 15 minutes, like the world seen through a fisheye lens. According to modern physics, the singularity in a black hole is a point of infinite density and infinitely small volume where space and time no longer apply the rules. Current physics cannot describe what happens after entering the singularity. Some scientists believe that the singularity may not actually exist, and entering it may take you to another space-time. Currently, apart from black holes, wormholes, and white holes have not been discovered, although both are predicted by the theory of relativity. After 13.8 billion years since the formation of the universe, it seems that only black holes exist stably. The complex space-time environment that wormholes and white holes need probably only existed in the early stages of the Big Bang. The closest black hole to Earth is GBH1, about 1,560 light-years away, located in the constellation Ophiuchus. This is a stellar mass black hole, about 10 times that of the Sun. The discovery of GBH1 is significant because it is not only the closest black hole to Earth known, but also the first dormant black hole discovered in the Milky Way galaxy. Unlike active black holes, dormant black holes do not actively suck in matter, therefore does not emit strong radiation, and is very difficult to detect. Scientists indirectly deduced the existence of GBH1 by observing the movement of its companion star. You are seeing the king of the rings in the universe, a super Saturn named J1407b. Its giant ring system has a diameter of 180 million kilometers, enough to connect the Earth and the Sun, compared to the rings of Saturn in the solar system, only 280,000 kilometers in diameter, and an average thickness of only about 10 J1407b is 200 times larger, completely changing the perception of astronomers about planetary rings located 434 light-years away from us. J4407b was not discovered by astronomers because its rings were too large to continuously obscure the light from the parent star. The 56-day cycle of brightness changes made astronomers realize that in this star system there must exist a giant object by analyzing the light curve and model computer simulations. Scientists speculate that this is a planet with a giant ring that causes this phenomenon when passing in front of its parent star. And this planet has been discovered. This is also the first exoplanetary ring system discovered by the transit observation method. The mass of J1407b is about 20 times that of Jupiter, surpassing the mass of the usual planet theory and becoming a strange celestial body located between the planet and the star. Some astronomers even believe that it has begun the process of weak nuclear fusion, passing from a gas giant planet to a brown dwarf star. But what makes astronomers more fascinated is its unprecedented ring system. Currently, more than 30 rings of different sizes have been discovered, forming a complex structure at a distance of 61 million kilometers from the center. Scientists also discovered a large gap, suggesting that a massive satellite may exist. There is a planet only 16 million years old. Astronomers believe that its rings are a special phenomenon in the early stages. In the next few million years, these rings will gradually coalesce into many large satellites. In the early solar system, Jupiter may also have many similar rings, then form dozens of its satellites by studying J1407b. Astronomers can better understand the formation and evolution of the planetary ring system as well as the mechanism of the birth of the satellite system. More importantly, if in the future a star without a planet is discovered, but the brightness still